Hello, class. So this would be the last of the recorded lectures for laws of cosine. And inside this section, there is another formula called Herons formula, where given all three sides, you can calculate the area. And it is actually quite useful because in most cases, it's easier to measure lengths of sides than it is to get at and figure out what the angles are if you're actually doing some mechanical design with triangles. And I think the good news is it's a pretty reasonable calculation as well. So again, much easier than chapter 4. so, uh, and so the way Heron's formula works is that you're given this value S, which is defined as the length of all three sides divided by 2. And then you could see it's the area equals this S times S minus A times S minus B times S minus C. And you just take the square root and away you go. And so for this calculation, let's walk through one. And so, for example, if we had a triangle that looked like this. So let's say this is 43, this is 53, and this is 72. And let's call them meters again. So we need to assign that. So let's assign this B, let's assign this A, and let's assign this C. So when you do that calculation, the first thing you want to calculate is S. And so S would be A plus B plus C divided by 2. And so that would be 53 plus 43 plus 72, all divided by 2. And if you get out your calculator, you would get 84. So the next step, the area is this crazy formula. So it would be, let me write it out again. So it's S times S minus A times S minus B times S minus C, multiply all that together, and then you take the square root. So a little tedious, but if you follow the process, not too bad, right? So S is 84, so this would be 84, and that would be 84 minus A, which is 43, and then 84 minus B. And so B is 53. And 84 minus C, which is 72. See it again, calculators a must on this one. So if you got your calculator out and did those calculations, you would get approximately 131.89. And remember, area is square, so this would be meters squared. So hopefully a good way to end it. The last of the formulas in chapter 3 is the Heron area formula. And so in summary, the last slide that will be uploaded gives a nice little summary of all the formulas now to calculate areas of triangles. Most of the time, you're given the 3 lengths, or you can measure the 3 lengths in real application. So Heron's formula comes in handy. If not, you have to measure an angle somewhere. And sometimes that might be a little bit more difficult. And so actually, practicality-wise, Heron's formula does come in quite handy with regards to the calculation. So what I'd like to end with is one kind of fun practical example. And this one, and I'm a big baseball fan. In my life, I've been to all the baseball stadiums at one time. In 2004, we finished our trek to every baseball stadium. And so it's kind of a fun problem. But here we're given, here is the baseball diamond. And this is a woman's softball field where the pitcher's mound is 43 feet from home plate, and from home plate to first base is 60 feet. And you see the angle between the home plate and the line from the pitcher's mound to home plate and first base is 45 degrees. So the question is, the pitching mound is not halfway. So how far is the pitcher's mound from first base? And so what is that? That is our A value. And so if you want to set this up, let me pull up the whiteboard. I'm going to hit pause here so I can write this out. Okay, so I turned off the recording there for a minute to draw this triangle. And so this is what the problem gives you. We want to find the distance from here's the pitching mound, PM, and here's first base. And one of the issues is we have these crazy formulas, right? But how do these correspond to our triangles, right? Well, remember that this angle and this, it means this is opposite. And so we've been writing these this way, where say like we call this angle C. So instead of this being our H, we could change it to variable C, right? And so this is the angle that we're dealing with. And so the other two sides would be A and B. And it really doesn't matter which way because we're not worried about calculating that angle. So the strategy is you want to calculate length C. And now what do we have? Well, we have adjacent angle and the two sides that are adjacent to that angle. So it's laws of sines. So again, if you remember, I will show you this formula one more time. So here's the one, the bottom one that we're going to end up using. And so let me just write that out for you. So we have C squared equals A squared plus B squared minus 2AB. And the key is, this is that angle C. And so if you put that in there, this would be 43 squared plus 60 squared minus 2 times 43 times 60. And you could see it doesn't matter which one's A and B because you could flip-flop them, you're going to get the exact same answer. C is the key, right? And so this would be 45 degrees. So let me find my answer here. And so if you got out your calculator, this would be about 1,800. And so if you took the square root of that, you would get about 42.4 feet. So the distance from the pitching mound to first base would be 42.4 feet. So hopefully that kind of clears a little things up. The strategy is to match the variables to what you're looking at. And sometimes that could be a little tricky. So that actually ends the recorded lectures for section 3.6, laws of cosines plus Herons area formula.